Welcome to this episode on binary and hexadecimal, two fundamental number systems used in computing. Understanding these systems is essential for anyone working with computers, whether you're programming, troubleshooting hardware, or simply curious about how digital technology works at its core. Let's start by looking at three number systems commonly used in computing. First, we have decimal, which is base 10, using digits 0 through 9. This is the system we use in everyday life. Next is binary, which is base 2, using only two digits, 0 and 1. Binary is the native language of computers. Finally, there's hexadecimal, which is base 16, using digits 0 through 9, followed by letters A through F to represent values 10 through 15. Binary is called the language of computers for a very practical reason. Electronic circuits inside a computer can only exist in two states, either on or off. These two states perfectly correspond to the two digits in binary. 1 represents on, and 0 represents off. This simple on-off mechanism is what allows computers to process all the complex tasks we see today, from displaying videos to running sophisticated software. Let's see how we convert a decimal number to binary. Take the decimal number 13. When we convert it to binary, we get 1101. This binary representation tells us which powers of 2 add up to 13. The rightmost one represents 2 to the power 0, which is 1. The next 0 represents 2 to the power 1, which we don't include. The one after that represents 2 to the power 2, which is 4. And the leftmost one represents 2 to the power 3, which is 8. Adding these together, 8 plus 4 plus 1 equals 13. Hexadecimal provides a more compact way to represent binary values. While binary can become very long with many zeros and ones, hexadecimal uses 16 different symbols. The digits 0 through 9 and the letters A through F, represent the decimal values 10 through 15. This compact format makes it much easier for programmers to read and write large binary numbers. For example, the hexadecimal value 2, FA9C4, is much shorter and easier to read than its binary equivalent. Here's an important concept. The same value can be represented in different number systems. Let's look at the decimal number 255. In binary, this is represented as 11111111, which is 8 ones in a row. In hexadecimal, the same value is simply FF, where each F represents 15. All three representations, binary 11111111, decimal 255, and hexadecimal FF, refer to the exact same numerical value. They're just different ways of writing it down. Hexadecimal is used extensively in computing. In web design, color codes use hexadecimal values. For example, the color code #FF5733 defines a specific shade of red-orange. Memory addresses in computer RAM are typically displayed in hexadecimal format, such as 0x7FFF5. A 2C network hardware uses hexadecimal for MAC addresses, which uniquely identify devices, like a 4:5E:6 0:E8:2 F:9D character encoding systems also use hexadecimal. For instance, \U0041 represents the letter A in Unicode. Let's recap the key points. Binary is the foundation of all digital computing because it directly corresponds to how electronic circuits work. Hexadecimal makes binary values easier to read and write by providing a compact representation. Both binary and hexadecimal are essential tools in programming and computer science, used daily by developers, system administrators, and engineers. Understanding these number systems gives you insight into how computers truly operate at the hardware level.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.